way.
All right, I think we're live.
We are live. First, I thought that I should send our stream link to Edmar as well. And then I'm like, no, that would be overkill. Hey, brother, where?
We'll show him, bro, over there. We'll meet him over there.
Like, brother, I think you have two candidates that can do office hours. But I think they
Mm,
are way ahead. Like, they are now on ISXM and all those things.
but bro, when I meet him in person, I'll tell him, brother, two streams that you did, render and visualization, and that fucking data exchange and data modeling. You fucked it up, bro.
Yeah. For sure, bro. Be casual in in your first meet as well. Be fucking casual. You know, man. Everything went well except those three fucking streams, man. They were like ridiculous.
Two.
Oh, two, my bad, two.
Bro, where is the fucking. What terminal is it? I can't find the terminal. B25. JFK to LAX flight is from NYC Kennedy. Where the fuck is the terminal? Fuck is the terminal? The hell? B25 is terminal 4, okay. JFK, New York Kennedy. Damn.
What happened?
It'll take me 1 hour to go to the airport, so I'll probably need to leave 3 hours before the flight, or 4 hours actually. So I'll leave at like 4.
And how are you gonna go?
Transit
Like, so,
subway.
oh, I guess I thought.
I can see if I can get the Uber that thing
Mm-hmm.
shuttle because I did do it last time and it worked pretty well.
Mm-hmm.
I just had to pay like $20.
Mm.
Bro, every time after the fucking chest day, my shoulder gives out. Fuck.
Graph LA soon.
25 bucks for the shuttle. Hmm. I think I'll just try to go by subway or something, not shuttle.
So how many trains would you have to change if you went with subway?
Two.
Oh.
It's not too bad.
Mhm.
I'll just have to take J and then go
Paying like six
till
bucks, right? In total, or
what?
you would be paying $6.
11.
11? Oh,
Yeah.
like
Bro, JFK is fucking in another fucking country.
oh man.
It's very far. It's like I'm crossing two states to go to one airport. Alright, bro, let's get started. Fuck this shit.
Whew.
Right. Let me. Alright, bro. Let's start this.
Mm.
We have already done this once,
Yes.
so it should not be that big of an issue. Let me just write my note. Yeah. Authoring point instancing. Hmm. Authoring point instancing. In this lesson, you'll learn about how to define point instancer, prims, understand the difference between point and scene graph instancing, and implement efficient large-scale scene representation. Here's what we'll accomplish: understand, create, and apply. Understand the concept of point instancing and how it differs from scene graph instancing. Create prim point instancing prims from external data sources. Uh, JSON, CSV, etc. And then create point instancer properties including prototypes, positions, orientations, and indices. Apply point instancing technique to real world production scenarios. Here's an outline of the lesson. Introduction to point instancing exercises, authoring point instancing. So, introduction to point instancing. What is point instancing? Point instancing is implemented a schema in OpenUSD, the point instancer prim type. Uh, is implemented as okay. Point instancing is implemented as a schema in OpenUSD. Point instancer prim type. Point instancer uses array attributes to describe points in 3D space. Point instancer uses array attributes to describe points in 3D space. Additionally, explicit prototypes represented by prim hierarchies in the stage are specified as relationship targets on the point instancer. By combining the points, prototypes, and indexed array to map the points to prototypes, by combining the points, prototypes, and index arrays to map the points to prototypes, OpenUSD is able to handle hundreds of thousands of repetitions very compactly in this vectorized format. USD geom point instance or detailed documentation to learn more about class USD geom point instancer. Okay, this is the one. So USD geom point instancer is basically a API schema which is inheriting from USD geom boundable, which is inheriting from exformable, imageable, USD typed and schema base.
Mm.
So that's the inheritance diagram of USD geom point instancer. Encodes vectorized instancing of multiple potentially animated prototypes, objects, instance masters, which can be arbitrarily prims or subtrees.
So point instancer inherits from schema base, right? Or schema base inherits from point instancer. How is it?
Point instancer scheme inherits from schema base.
And boundable and then exformable and then imageable. Okay, imageable covers exformable and boundable. Boundable only covers instances. Okay, bound. So okay, makes sense.
One second. Okay. So compared to scene graph instancing, point instances can be less user friendly and trickier to refine because most of the scheme description is hidden away in large arrays that are not as human readable. Point instancing is designed for massive number of simpler items where the overhead of an instance outweighs the benefits of use. Point instancing is designed for a massive number of simpler items where the overhead of an
Bro,
instance
your voice is breaking.
outweighs.
Like I think there's some issue with your voice. Yeah. Say again.
Yo, yo, yo.
Yeah, now it's clear.
Yes. Point instancing is designed for massive number of yes, we did this. What does this mean? Think about leaves on a tree. You might have 100,000 leaves on a tree. If you started down the path using scene graph instancing for this, you would need to define each leaf repetition, and you would end up with 100,000 instanceable prims. Okay, leave 001, leave 002, blah blah blah. Do you really need this in your scene graph? Is this useful data for anyone? Okay. That's where point instancing is a clear winner. How does it work? We will walk through a concrete example of point instancing packaging peanuts within a box. A single box may not have a lot of packing peanuts, but they are not prims. We want to enumerate our scene graph. Oh, yes, I remember now how point instancing works. Uses array attributes to describe points in 3D space. Additionally, explicit prototypes represented by prim hierarchies in the stage. We talk about okay. A single box may not have a lot of packing peanuts, but they are not prims. We want to enumerate in our scene graph. So def point instancer, packing peanuts. So point instancer is a schema base type. It's a typed API schema, typed schema, point instancer. Rel prototypes. So it has one rel prototype that is defined somewhere.
Hmm.
Prototypes peanut one. Okay. Proto indices are in proto indices. So this is 0 and this is 1, and proto indices are defining what they are gonna be. So 0 means prototype peanut 1, and 1 means prototype peanut 2. Point 3 have positions, orientation, scale, over scope, um, prototype def peanut 1. So references peanut.usd, which is not here, but it might be defined somewhere else. But
Mm-hmm.
and then variants string color is equal to blue and string color is equal to red. Okay. Point instancing is a schema based instancing solution. We need to start by defining a point instancer prim. Okay. The point instancer includes the following mandatory properties: prototypes, proto indices, and positions. Prototypes, proto indices, and positions. Hmm. Point instancing is schema based instancing solution.
I think we did had a question regarding like mandatory properties, like an MCQ, and there were like four properties, and out of which you have to select which are the correct ones that are going to be mandatory for them. So
Mm-hmm.
proto indices and positions that are going to be the mandatory one, and orientation and scales are optional. I think this is the one that went wrong for me, I guess, but I did mark orientation
Hmm.
as a mandatory one.
I think the question, this question was in our quiz. It was not in the. That was, I don't think that was the question.
Of them are optional. IDs is an optional attribute if you want explicit control over integer ID of each instance. Otherwise, each instance ID is referred from element and
Point instance. So we need to start by defining a point instance for prim. Yield the following mandatory properties.
Otherwise, each instance ID is inferred from element index and proto indices array. Example index 0 and proto indices is instance ID 0. Hmm. Point 3f positions, path
A
orientation.
relationship targeting the prim hierarchy that point instances should use as instance prototype. Targeting the prim hierarchies. Produce as instance prototypes. The a relationship targeting the prim hierarchies that the point instances should use as instance prototypes. Proto-indices declares an instance of a prototype. Declares an instance of a prototype and maps up. Hmm. Genuine demand. Storage positions, points in local space where each instance is located. points where each instance is located. Mm. Orientation and scales are optional but can be used to fully pose each instance. Mm. IDs is an optional attribute if you want explicit control over the integer ID of each instance. Otherwise, each instance's ID is inferred from the element index in the proto indices array. Example, index 0 in proto indices is instance ID 0. I think we did have a question on this in the quiz, in
Mm-hmm.
our quiz, not the final quiz.
Mm.
This part. Each instance is inferred from the element in the
Yeah.
element index in the proto indices array.
Okay, as a best practice, we define prototypes under scope as descendant of point and sensor. Okay, yeah. I think this could be a question.
We define the prototype under a scope as a descendant of the point instancer. Unlike implicit prototypes in scene graph instancing, you need to explicitly define each of the prototypes. You need to explicitly define each of of the prototypes for your point instancer. We purposefully use an over specifier for the scope to keep the prototypes from being traversed by default traversals. We purposefully use over specifier for the scope to keep the prototypes from being traversed. Okay, so what is it saying? As best practice, we define the prototypes under a scope as a descendant of the point instancer. Okay, but this is not a scope. Oh, prototype under a scope like this. Okay,
Yeah.
and it is done as an over so that it is skipped by a default reversal.
Mm.
This is a way that we can signal that these prototypes don't need to be rendered and should be skipped. The instances are typically what we want rendered. I see. Let's spend a little bit of time breaking down the how the points are mapped to prototypes. In the example, proto indices show 0001. The integers represent an indices in the prototype array. 0 maps to prototype spinnet 1, and 1 maps to prototype spinnet 2. Um, this meant that the first 3 points are using prototype peanut 1, and the following point is using peanut 2. Okay. We are over here. Many point instance properties are array attributes. Bro, give me 1 minute. Ah, I fucked up my shoulder.
What happened, bro? The fuck?
I fucked up my shoulder.
What the fuck did you do? Like,
Bench press
oh,
and like incline dumbbell press
oh.
or upper chest, followed by uh, hmm, All right. Hmm. Well, many of the point instancer properties are array attributes. Hmm. Many of the point instancer attributes are properties are array attributes. There is no easy way to ask us for information about individual instances here. Much of the data has been vectorized. You potentially have giant array of position on orientation and scales, etc. You have to index to those arrays yourself to query data about a particular instance or to override any of them. Additionally, at the moment, there is no way to do sparse overrides on arrays. If you want to move even just a single point in a point instance, you need to author the entire positions array again for a new opinion. Hmm. Mhm. Mm. The prototypes are defined under the scope of the point instance. Unlike implicit prototypes in single instances, Implicit meaning.
That happens automatically, I guess. Like it's gonna get generated
Hmm.
no matter you define it or not. And explicit means that you have to define that prototype manually. So
Hmm.
instancing automatically defines any prototype. So for example,
Hmm.
when we are trying to reference a file and we use instanceable equal to true.
Yeah, so in scene graph instancing, the prototype gets generated by USD, and over
Yeah.
here we're creating the prototype ourselves and referencing it to the
Yes. Yes.
array of the points instancer. And mhm. I think this was the question in the quiz. What is the main difference between native instancing and point instancing?
Oh, yeah, yeah. Native instancing. Yes, yes. There was a question regarding native instancing.
Native instancing is scene graph instancing only.
Oh, fuck.
Hmm.
Fuck me.
You need to explicitly define each of the prototypes. For a point instance. Okay. We purposefully use an overspecifier for the scope.
Fuck me. Oh, my fuck.
To keep the prototypes from being traversed.
There it is. Dude. Oh, no, nothing. Fuck.
Or
It was irrelevant. Like my roommate was telling me that there's a new sushi joint, all you can eat sushi joint that is opening next week in Tallahassee. But then I was like,
I
okay.
think we've already been to one.
It was not
I think.
all you can eat. It was like, okay, you pay, you eat.
No, you just that was all you can eat. It was a buffet, right?
Which one? Oh, no, no, that dude, not that one. That was
What
that
was that called?
chow time, bitch. Chow time.
Chow time, chow time.
Chow time, bro. That is the only thing. So the only best part of that place was the sushi. Apart from it, and the hibachi. Yeah, hibachi. I would have
Mm.
eaten hibachi. So my roommate was like, "Okay, let's go. Do you wanna go with us next week?" I'm like, "Yeah, for sure. Definitely, a new joint is opening." So
It's opening next week.
yeah, next week, like because it's opening next week. So next week.
Mm.
Maybe because like the thing is, the other guy that lives with us, not with us, but
Mhm.
down below, he
Mhm.
usually works in the night, and he's a real Batman, I would say. He is the real Batman. He works at Clyde's, Potts, or Reese's in the night, and then sleeps the whole day. He would, I would
Mhm.
always see him like smoking something in the morning, 7 a.m.
Mhm.
And I would say, "How's work?" And like, all good. And what's your plan for now? Gonna sleep. He will sleep the whole day and then go to work.
Damn.
And he's doing some kind of environmental study or something like that. I don't know.
Yeah, bro. Even your older roommate, that guy, I
Ooh.
don't remember his name, who used to have like a tub for all his essentials in the bathroom.
Which one are you talking about? Like wait, which apartment are you talking about?
University Village.
Oh, okay, okay, yeah, man, yeah.
What was
Oh,
it?
yeah,
Geo.
bro. Yeah, bro. I remember that guy.
What's his name? What was his name?
Josh. No, Jake.
The one with like glasses
Yeah,
and
yeah, he was Jake. Bro.
yeah. And then what happened to that NBA player?
I don't know, bro. He's doing NBA in his life. You know what he used to do? He would smoke the pen, like the THC oil, and then just sit. And I said, bro, what I'm doing, I'm focusing. No, bro, you're high as fuck, motherfucker. You are focusing my ass. And then you just come to, bro, it's all about focus. I just want to get into the NBA and the big leagues. I have some auditions coming up at Arizona State and all that bullshit. I don't know what happened to him.
Mm,
I think he got evicted or something like that. Yeah, bro, I don't know. Like, he used to do some shady shit. Like, he was always short on
mm,
cash. I'm like, man, what the hell?
Mustang.
He used to work at, what was the place called? Holiday Inn or something like that.
Oh yeah, like a receptionist friend.
No, 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 my ass, he's gonna be a receptionist. Look, you should look at his face. He was the guy that would do housekeeping.
Damn. Alright. Me purposefully use over specify. Yes, this is the way that signal prototype don't need to be rendered or should be skipped. Instances are typically what we want rendered. Let's spend a little bit of time breaking down how the points are mapped to prototypes. Example, proto indices show 0, 0, 1. Yes, we know this. We know this. This means that the first 3 points are using okay, yes. Many of the point instances properties are array attributes. Hmm. There's no easy way to ask us for the information about each individual instance here. Much of the data has been vectorized. You potentially have giant arrays of positions, orientations, and scale. Positions, orientations, and scale. Hmm. Okay. You have to index into those arrays to query data about a particular instance. You have to index into those arrays yourself to query data about a particular instance or override any of them. Additionally, at the moment, there is no way to do sparse overrides on arrays. If you want to move even just a single point in a point instance, you need to alter the entire position array again for the new thing. A point instance or override requiring full array for each time sample. Hmm. Orientation time sampler. Point time sampler. Hmm. Keep this in mind as you perform downstream overrides and considerations you may need to make about the things like USD layers format, that is USD versus USDC computing instance transform. When you specify positions on point instancer, you're defining positions in the point instancer's local coordinate space. When you specify positions on a point instancer, you're defining positions in the point instancer's local coordinate space. However, when USD computes the final world space position of each instance, it combines multiple transforms together. When USD computes the final world space position of each instance, it combines multiple transforms together. Hmm. What does this mean? When you specify positions on a point instance, you're defining positions. When you specify positions on a point instance, you're defining positions in the point instance's local coordinate space. Okay. However, when USD computes the final world space of positions of each instance, it combines multiple transforms together.
Saves all the transformations that you have onto your prim, and then, so no, sorry, it applies all the transformations and then saves the instance in the memory as the final composed value. So for example, let's say you have a prim and you're trying to apply scale, rotate and translate along some axis
Hmm.
on something like that, right? And you are doing it in
Hmm.
sequence. So when you're trying to do that, what happens over here is when the point instance comes and says, "Yeah, let's create an instance." So what instance creation means is to create a
Hmm.
shared copy into the memory. And the goal of the instancing, what is the goal of the instance? The goal of the instancing is to reduce memory usage as much as it can, right? So
Hmm.
to do that, what it does is it pre-computes all the translation, all the transformations that you have on that prim, and then combines all of them all together
Hmm.
and saves it as an instance directly. So that's what it means over here.
Hmm. I didn't get it. What?
So you have a prim, a
Hmm.
cylindrical prim, and on that prim you're
Which frame?
a,
Which frame?
cylind- a cylindrical prim,
Cylindrical frame. Okay.
and you're trying to apply scale 2x and then translate 10 degrees along x axis, and
Mm-hmm.
maybe a rotation, a 90-degree
Mm-hmm.
rotation or something like that, right?
Mm-hmm.
So when you do it, when you compose the prim will apply them one by one, right, every time,
Yeah.
right?
Yeah.
But if you use instancing, the prim will
Mm-hmm.
have the cached copy of the complete
Mm-hmm.
transform that you want to
Mm-hmm.
apply.
Mm-hmm.
And so the transform will already be completed. Like when the instance is loaded, there won't be any transformation that will be done, since the
Mm-hmm.
transformations were already cached into the memory.
Mm-hmm.
So that's so over here what this example shows multiple transforms put together. You have
However, when USD computes the final world space position of each instance, it combines multiple transforms together. When USD computes the final world space position
yeah
of
what
each instance,
what would be the final position of after applying all the translations or all the transforms? Like you have
mm-hmm.
rotated it in 90-degree, you have scaled it 2x, and you have
Mm-hmm.
moved it along 90 along x-axis. So what is the final position that you will have? So that would be saved
Mm-hmm.
as in your instance. That's what it means over here.
Okay, for each instance, USD applies the following transformation in order. However, for each instance, USD applies the following transform in order from most local to least local. Prototype's root transform. The local to parent transformation of prototype roots is applied most locally. The local to parent transformation of the prototype root. Instance specific transform. The per instance transformation is applied next. point instancer, scales, orientations, position. Okay. Point instancer prim transform. The transformation authored on the point instancer prim itself is applied least locally. This means that you can move an entire point instancer around your scene by transforming the point instancer prim. This means that you can move an entire point instancer around your scene by transforming the point instancer prim. And you can have prototype with their own local transform that will be incorporated into each instance final position. Mm-hmm. Mm-hmm. I am just confused about this last part, bro.
Ask AI then.
That's what I'm doing.
Mm.
CGO point instance. Static public.
Peach. Peach.
So it's saying positions I is not a world space location, it is a translation. Bro, what the? Hmm. Position I is not a world space location, it is a translation inside the point instancer. Prince coordinate system to place an instance in the world space. USD starts with prototype's local geometry, applies the prototype root transform, then the instances scale, orientation, and position. And finally, the point instance of prime is and transform and any ancestor transforms. And any instance in the world space applies the prototype root transform Then the instances scale, orientation, position, finally point instances, trims, transform answers to position. Okay. Prototype local point, prototype local root transform, scales I, orientation I, positions I, point sensor. Trim transform, transforms of ancestor above the point. Oh, I think I understand what it's trying to say.
Mm-hmm.
It's saying that the transformation data that is going to apply on an instance is going to be chosen from the most local value present.
Mm-hmm.
Usually starts with the prototype's local geometry. Applies the prototype root transform, then the instance's scale, orientation, position, and finally point instance trims, transform, and any ancestor trims. Ancestor transforms. Okay. Think of one point on the prototype moving outward through coordinate spaces. Think of one point on the prototype moving outward through coordinate spaces. Prototype local point, prototype root transform. Yes. Okay. Okay. Position. Oh, this can be a question, bro. Position and the point instead prim itself has this with no prototype roof offset. No prototype roof offset scalar orientation instance position and point instance of space.
Since point instancer is pointing to 100.
Point instance of power position in world. Final world position is okay. Point instance and world. Ah, okay. Prototype root translation 010 instance scale 222 instance orientation 90 degrees around Z instance position 1000 point instance translation 100 start the point at prototype origin. Okay.
The prototype given instance skill to 2 round, instance position 10, comma 0, point instance translation 100. Start with 0, then we go to 1, and then scale it by 2, and then after doing it, we do 90 degree, and then after that, for instance position, we add 10, and then in the final position. Where is this? What is this point instance prim transform? What is this 100 over here? Oh, translate along 100. Okay, x axis.
Point instance translation, like the
Translate
actual local opinion of the
form,
translation on
right?
the
Form,
point
right?
instance.
Or what is it? It's an
Wo-
X form, right? Or what?
transform.
Yeah, yeah.
Point instance. I don't know what it is. I think
It's
it
a
should.
local
No,
translation. That's it.
it's a local opinion, translation opinion. The border space position is 108. Okay. Okay, over here. So double three exom OP translate like this. This is this that you were asking.
Yes, 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 yes.
This.
Oh no, no, it's not that. It's not that. It says 100 over there. It's gonna be down by.
No, I'm just saying example like an example.
Oh,
That's
okay,
what it means.
okay, okay. La 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 la. La 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 la.
Mm, Real prototype. Mm, This is the coordinate system in which prototype geometry is modeled. But I didn't understand this part clearly. Oh no, I understand this, but let me read this once more. When you specify positions on point instances, you define the positions for however, USD computes the final workspace position of each instance. It combines multiple transforms together. Oh, so this is what this all means. Combining multiple transforms together. For each instance, USD applies following transforms in order
Mm-hmm.
from most local to least local. Mm.
Least local means.
Bro, what if they ask us that they'll give us a code like this,
Mm-hmm.
and they'll say, okay, what is the final position of let's say Where have they instanced it, bro? Of the boxes prototype.
Mm-hmm. Final
No, but
position of boxes prototype.
hmm,
Oh, like 10, and then we scale it to 2, and then we pop out.
we'll start from 100, right?
No, we won't start from 100. Why would we start? No, no, we will first scale and then do orientation and then position. Like, look at the order for applying transformation.
Start with point at prototype's origin, prototype root transform. So prototype's root transform is prototype's root transform, bro.
Local. So there is no root transform for a local right now. There is a local. So next would be Q prototype. That would be applied.
010.
No, first scale would be applied, not translation, I guess.
Where is scale?
But there is no scale, so next would be orientation and then position. Oh, what the fuck? The per instance transfer applied. Like, but in over here it says scale, then orientation, and then position.
Where are you reading scale and or instance specific? The per instance transformation is applied in this order. Scale if author, orientation if author, and then position. Hmm. The instance translation is applied after its scale, rotation, and orientation. So the value of 1000 is not itself scaled or rotated by those point instance transforms. In point instancer prim transform move the entire instancer by 100 Let's see what it's saying. USDA example, we know what it's saying. Okay, what each relevant line means. Rel prototypes, world prototypes, cube prototype. So rel prototypes, world prototypes, cube prototype. The first prototype available to the instancer is cube prototype. Okay. Mm, In proto indices 0.3 F position 1000 float 3 scales 222. Instance 0 uses prototype 0, which is Q prototype. Zero point 0.3 F positions 1000 place instance 0 10 units along X. Yeah, see, it's using the local opinion first for proto, and this is what it's doing. Prototype root transform. Okay. Place 0 10 units along X. Uh, and then scale is 222. Scale instance 0 by 2. What?
First position is applied, and then scale is applied, and then how orientation is applied. How is that being done? Doesn't it contradict the same thing that is written on our left hand side?
Bro, that is applying the prototype root transform first. This is prototype root transform. The first prototype available in the instance is Q prototype. The instance uses prototype target 0, which is Q prototype. And this is point transform, point prototype root transform.
Oh.
And
Inst-
then the scale comes.
oh, and then the
So
orient.
scale is this, scale 0 by 2. And then orientation is this. That is what is given, yes. Rotate instance 0 approximately by 90 degrees. So around Z. Yeah. Move the entire point and sensor. Hundred units along X. The three coordinate spaces prototype local space cube prototype geometry vertex might be 0.5. Prototype in sensor local space. Okay. This means you can move an entire point and sensor around your scene by transforming the point and sensor trim. You can have the prototypes with their own local transform that will be incorporated into each instance final position. Mm-hmm. SOP scale orientation position point and sensor. ESOP. Look at this, bro. What is point and sensor? And system prototype through translation. Scale orientation is position. Yeah, position and then prototype root transform. This is the prototype root transform. Okay, bro, I am clear on this. Do
Mm-hmm.
you wanna?
No, I'm also good with this prototype root transform and then specific transform
Yeah.
for instance. Please no, make a note of it. Once Prototype root transform first. Uh,
Hmm. Let me just note this. All right. Oh shit, bro, my fucking shoulder. Where's the Geom point instance, sir? Class reference.
Bro, what do you say? Should I sell the whole system for 400?
Yeah, bro. You're not getting any other deals. So why are you waiting on it?
I'm just trying to get the most out of it.
Bro, you have to cover, know, your what is it called? You have to take into the consideration the time you're putting into that. Your time is worth
Yeah,
more.
like yeah, but I'm also getting a PS5 as well, so that's what I'm thinking that I will also flip that PS5 for more cash, and then yeah.
Up to you, bro. But ask if like what is that PS5 specs? How old is it?
It's PS5 disc version with two controllers.
But like how old is it?
Oh,
Because he might scam you, bro. You never know if that PS5 is working or not.
yeah, yeah, sure. I will definitely ask him for proof, like proof and everything.
How are you gonna ask him to like come to your house and plug it in and
No, no, I'm gonna ask him for a video proof of him playing on the PS5 and all. Usually, on like that is the risk you have to go with on Facebook Marketplace. That is the thing. Like, what?
AI generated?
Let's see, bro. Like I usually talk to people when they have a good profile. That's how like I do my ballparking for them. Like if they have good ratings and all those things, and how long have they been on have they been on Facebook and all those things.
Certified scammers.
Yeah, but usually like scammers they do have profile like okay recently joined or something like that.
Mm-hmm. Mm-hmm. But
Oh.
there was this one streamer
Mm-hmm.
who used to who streams like him doing DJing, like
Mm-hmm.
mixing music and all that stuff.
Mm-hmm.
And he went on TikTok live
Mm-hmm.
and he forgot to plug in the music input
Uh,
for
3 hours.
the for console, like for his deck. So whatever music he was playing, he was able to hear it on his headphones,
Mm-hmm.
but the audio was not translating to his live video.
Mm.
And people started pranking him. They're like, "Oh my god, those beats are sick."
Oh.
And that joke got so big. He was like, "Bruh," I was like doing all this. Yeah, yeah, yeah. And there was no music.
Damn.
And people were like, "Oh my god, the beats are so sick, bro. You're fire." And he went viral because of that. Oh, USD gem point instances stores many lightweight instances by keeping one ordered list of prototype names and compact. For instance, arrays that say which prototype to use, where to place it. It's not geometry itself, so it is not a GPRIM, however. Me gusta le con falda. USD Jump Instance stores many lightweight instances by keeping one ordered list of prototypes. One ordered list of prototype trims and compact per instance array that say which prototype to use, where to place it. It is not geometry itself, so it is not a G-trim. However, it is boundable because of the complete collection still needs a bounding box for rendering, framing, and culling. Big picture example, suppose you want to scatter trees and rocks. Available prototypes: index 0, tree, index 1, rock, index 2, bush. Index 0, okay, instance 0, prototype 0, which is tree. Okay, point instances. Instead of duplicating the complete tree or rock hierarchy many times, USD stores prototype geometry once, plus small arrays describing each instance. USD mm, prototypes. Dev scope prototypes. Xform tree, this, Xform rock, this, Xform bush, this, okay. And then point instance of scatter, val prototypes, embodied prototypes, trees, more prototypes, and trees. And then that is referenced by int proto indices 0, 1, 2, 0, 2, 0, 1, and 2. So 0, 1, and 2. Positions, orientation, scales, how the prototype relationship works. Yes, we know this, we know this, we know this, we know this. So this was just fucking a complicated way of telling the same thing, actually. What
Mm.
the fuck is wrong with these people? Bro? Why can't they just create like a simpler documentation?
Why would they? Why would they? Elites keep things complicated so that not most people can tap into.
They want people to get USD certified. Why do I feel like we are getting pulled into a big scam?
Dude, if it's a big scam, then Nvidia is also a big scam at this point.
$1 trillion company, not it's everything like nobody's a saint, bro. Nobody that is a saint, they make it big.
Mm.
There's some shady stuff that everybody does.
Everybody has to, bro. That's bureaucracy. That's bureaucracy.
Bureaucracy. How is that bureaucracy, bro?
Bureaucracy. Because in a way that you have to talk with people, make relationships, and then bend to their rules or do something that go against your morals.
Mm,
Maybe like doing some things that are like that are evil. Just
Diddy party.
what?
Diddy party. Ain't no party like a Diddy party.
uh, Maybe because that's what OpenAI is doing as well, bending the fucking rules. It's stealing
Yeah.
the hardware secrets of Apple.
How is that going? Like, how's that lawsuit going?
I don't know, man. Like I think they might have some kind of hearing or something like that.
Oh, that is why they switched from OpenAI to Gemini.
Oh yeah, because ChatGPT was also like trying to store their information on the servers. Most of the company
Mm,
should follow their SLAs, but usually they don't.
mm.
Greedy as fuck.
Yeah, bro, Johnny Ive is the fucking mastermind behind iPhone and a lot of things that we are a fan of.
Mm.
That's what they were trying to get. They were trying to get Johnny Ive on. Bro, do you remember that website that I was trying to show you, and they were like, "We will find you. You don't find us."
Yeah.
Love form, yeah, this one.
Oh yeah, love form. Like this is from the Apple designer, right?
Yeah,
Yeah.
Johnny Ive and Mark Newson. Hardware user interface packaging major architecture project. Either iMac, iPod, iPhone, iPad, and Apple Watch. 14,300 design and utility patents. That's crazy. Are they on LinkedIn? Love form?
What? What? Did you say something?
They're not on LinkedIn.
Oh. Yeah, these people tend to go away from LinkedIn because they have already made so much reputation out over there in the market. They don't give shit about petty people.
Mm, Never mind. We're gonna get there, bro, soon. Oh, there's this book that I wanted to. That is like my next.
Oh, you already
Uh,
already done with the cybernetics?
no, I've completed like one third.
Mm, I see.
No, but I was like scrolling today, and I went to this place
Hmm.
called
Oh, Zolo?
Rizzolo
Oh, Rizzolo. Wow.
bookstore, Rizzoli bookstore. Sorry,
Wow.
this. It's really good. Like it's really pretty.
Hmm.
And I saw like a design book on design.
Mm-hmm.
It was let me see, Bruno Munari, design and visual communication.
Hmm.
This guy, Bruno Munari, design as art. This book. he has inspired a lot of designers,
Oh.
like product and I read like a couple of pages and I liked it.
Hmm. Interesting.
Anyway, all right, I'm just gonna read this real quick and then we can move on to the next thing. Encodes vectorized instancing of multiple potentially animated prototypes, which can be. But where is Python going for like full stage flattening? My bad. Replacing the target at particular index is safe when that is your intention. But reordering the relationship targets changes the meaning of every proto indices value. Why split transforms into arrays? Instead of storing one 4 by 4 matrix of every instance, point instances store separate arrays, position, orientation, scale. Mm-hmm. Mm-hmm. The point instance ah. Mm-hmm.
Hmm.
Look at this. Do you get this?
Oh, the math. Three floors, 12 bytes. Four halves, 8 bytes. Three floats, 12 bytes.
Mm-hmm.
Hmm.
The spread representation also lets you animate only when USD geom point instance. By point instance is not a G prim. Mm-hmm. We are just gonna do it till 1:30, bro, today.
Okay. I was gonna tell you till 1 because I need to sleep early. I have an appointment at 8.
Oh, yeah, okay, we can do it till 1.
Yeah.
Because I need to sleep as well because I woke up at 9 and I slept at like 4 yesterday.
Oh yeah, dude. I also woke up at 9, so I slept for like 6 hours. Wait, you slept at 4? Why?
Like I slept at 3:30, but
Same. Same. I also slept at 3:30. I was trying to read the book, and as soon as I started
mm,
reading the book, 4 or 5 pages down, I started to feel sleepy.
yeah. And, oh no. Why it is boundable? This is interesting. USD geom point instancer is not a GPRIM. Oh, GPRIM is a geometric primitive that directly describes renderable geometry. A mesh directly stores surface information. Hmm. Bro, I was doing the math today.
What? Mac?
Math, math,
What? Come again? Math or Mac?
math, bro. MATH.
Oh, math. Okay, okay, okay. Math.
Whenever I go out
Uh-huh.
in the city, like whenever I go to the office, and you know,
You,
whenever I go to the office,
yeah.
I spend around like $40 every day.
Every day.
Yeah, like somewhere or the other. Like either I'll get coffee.
Hmm.
The subway is like $6, and
Six
then I'll get
dollars.
some.
Oh, Subway. Okay, okay. I see. I thought.
Uh,
Hmm.
like both ways, like going, coming, and going
Hmm.
round trip.
Nice.
New York is fucking expensive, and there is so many things to do that you already like.
And
I
New York
always
is
end
like,
up.
52 around, like, I don't know. There's a number. So basically, if you go out every day
Hmm.
for 10 years or 12 years, you would be still going to a new restaurant every fucking day.
Yeah, exactly.
There are so many restaurants.
So that's why I just keep exploring, going around. Mhm. Successfully healed my past, bro.
Successfully build your patch.
Healed. Like the thing that I had over here. Do you remember?
Oh yeah, 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 I do remember. There was a wormhole, white hole.
I don't know why it happened, bro. I still don't know.
No worries, bro.
Good nutrition, and I didn't cut my hair for a year. And came back. All right. A mesh directly stores surface information. A point instance does not directly describe a surface. So that's why USD gem point instance is not a GPM. Why it is boundable, even though point instance is not direct geometry, the collection occupies the space. Suppose the instance from a forest. The application needs to know overall spatial boundary for this. Being boundable means the prim can have extent representing the local space bounding range. Alright. Treated similarly to a procedural. A procedural generally tells the renderer or consumer how to produce geometry rather than directly storing every final geometric element. Point sensor behaves similarly. Input description, prototype indices, transform, consumer. G-prime versus point instancer. Directly describes geometry, no. Examples, mesh sphere, cube, point instancer, stores, point, safe, traces surface data, usually no. Selects other prints as prototypes, yes. Can represent billions of repeated objects, yes. Is boundable, yes. Has an overall extent, yes. Primary low renderable geometry vectorized object distribution. Python example. This is the Python for point instancer. Create prototype rel, create prototype indices, attribute, position attribute, create scale attribute. Mm-hmm. Not identical individual prints marked instance of prototype generated by USD stage. One point instance of print explicit prototypes, relationship vectorized, for instance, array. All right. I'm just gonna read this quickly. The point instance is a multi-instance as a development of prototypes to be scattered among its points. We use US relationship prototypes to identify and order all the possible prototypes by targeting the root prime of each prototype. The ordering imparted by relationships associated as a zero-based integer with each prototype, and it is these integers we usually identify the prototype of each instance compactly, allowing prototypes to be swapped out without needing to be reauthored. All of the per instance data of the point instancer schema is designed to scale the billions of instances, which motivates the choice to split the per instance transformation into position, quaternion orientation, and scales rather than 4 by 4 per instance, in addition to requiring fewer bytes even if all elements are authored 32 bytes versus 64 for a single precision 4 by 4 matrix. We can also be selective about which attribute needs to animate over time for substantial data reduction. In many cases, note that prim point instancer is not a GPU, since it is not a graphical primitive by any stretch of the imagination. It is however boundable since we sometimes want to treat the entire point instance similarly to a procedural from a perspective of inclusion of framing. Hmm. So we covered a lot of stuff from what do you say, content aggregation.
Yeah.
We've already done scene graph instancing yesterday.
Mm-hmm.
We already done extensible categorization kind hierarchy. This is the assembly model assembly kind group and then component.
Hmm.
And then important property USD shared node graphs, detailed description. Yeah, this is the only thing. I think this we'll do later. This
Okay.
we'll save for tomorrow. So we can close that. We can just take a look quickly at authoring and refining.
Excuse me.
So this is important. Refinement using trim bars. So this is very important. Point instances, refinement using trim bars.
Where using vertex interpolation will be applied, for instance, like scene graph instancing. You can introduce a lot of diversity in your point instances by using prototypes that read firmwares. In the case of our packaging peanut example, our packaging peanuts asset material network may read from firmware's peanut color firmware. Authoring this firmware on a point instance could enable us to make each peanut a different color if you wanted to. Oh, firmware as an array, right? Yeah, 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 yeah.
Mm-hmm.
Mm.
Overpacking peanuts. Hmm. So if you want to introduce more variety into a point instances with additional prototypes, point instancing the explicit prototype pattern requires a bit more work than scene graph instancing. You will need to define an additional frame hierarchy for the new prototype, add a new prototype to the prototype's relationships, update proto indices to specify each. Yes, refinement using visibility. Oh. Visibility and deactivation at any point in life downstream. You can define their point instance by pruning. Mm, or hiding instances using inactive IDs, metadata, and invisible IDs attribute respectively. A good rule of thumb is that you need to animate an instance on and off over time. You should use invisible IDs, otherwise use inactive IDs. A nice feature of inactive IDs is that it can be list edited, so you can sparsely add and remove IDs. This is important, bro. We have
Yeah.
if you need to animate an instance on and off over time, you should use invisible IDs.
Firstly, list edit invisible inactive IDs.
We have answered a lot of questions based on this.
Sparsely editable inactive IDs. Motivation, we got motivation, bro. From cash.
Motivation?
No, bro, nothing. Like it says over there, motivation objects in the scene graph, prim cache, PCP.
Oh. Mm.
Bro, every time I'm opening trading view, there's a fucking new indicator. Tiger is giving it hard. There is no new fucking technical indicator.
Bro, what is the fucking trading view? I also want the access. I fucking paid for
Dude,
that
I
shit.
do. You have, dude, I have shared the credentials so many times. I think you do have access to it. Open it. Yeah, click on it. I don't know if you logged in or not.
I
No,
don't think I've logged in.
no. Go to. Okay, we will do it.
Oh yeah, 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 yeah. I think I have.
Yeah.
This is the one, right?
Yeah, this is the one. Yeah, there you go.
Where are the fucking charts?
Right, like go to click on any stock. Yeah, click on it. Now go to full chart over there. Like, yeah.
Mm.
And these are the indicators that Tiger is always adding or removing. And then if you change the time frames like daily, weekly, then you can get more.
Where is the? I want to take a look at.
You want to
Where
search
is?
a stock?
Yeah, but that's fine. Oh, these are the indicators that Tiger has created.
Yeah, like created or got has loaded onto the view.
So far, his support zone is where this red line.
The block. Like zoom out
Mm-hmm.
and go to change the time frame to weekly. Go up, like on the top. Go on to the top. And then, yeah, next to SoFi ticker. Yeah, it's 4 hour. Now change it to weekly. Yeah.
Mm-hmm.
Right click. Yeah.
Mm-hmm.
No, not right over. Like on any open space. Yeah.
Mm-hmm.
Reset chart. Reset the first one. Yeah.
Mm-hmm.
Yeah. This is the support. Like the block that I have given, created the green box. That is the
Yeah.
support for SoFi.
Mm.
Unless we can see it bounced from like 18. Uh,
Over here.
yeah.
Mm.
That becomes a support. And then there was a heavy resistance at 24. So
Over here.
no, 24. Resistance means like that.
Oh, like
Yeah. So
people are selling.
yeah.
Mm. And what is this? Yellow, red,
Yeah.
blue.
This is something that Tiger has added. I don't know about that.
Mm.
I don't do a lot of indicators.
Mm.
I would only follow like basic SMA, all those things. Like if you want to take a look what indicators we have, uh, you can go on top right. Sorry, top
Uh,
left. Go to left and a bit down below. Yeah.
indicators.
No, like no, not over here. Technicals. These are the indicators where you can add, but the one that we can see
Mm.
right now is like click X on this. Like over
Mm-hmm.
here, where go down, wait, but go down a bit. Move your cursor a bit down.
Mm.
Yeah, you see it says SMA, KC, wall on.
Yeah,
Yeah,
yeah, over here.
so those are the indicators.
Mm.
So like if you hide any of them, then it's gonna like you can click on the eye logo. You see there's an
There's,
yeah. So it will hide.
oh, I.
So it will hide
Oh,
what indicator is what accordingly.
I see. I hope Tiger has my wishes,
Yeah, bro.
best wishes.
Yeah,
For
Tiger
Tiger.
works. Like Hood is going up, so Tiger is happy.
Yeah, I have 40. What
Nice. I don't. I sold all of my Hura. Like nah, I'm out of Hood right now.
what do you sell it at?
I think I sold it at like I think 100 or something like that, 100 or 80.
Yeah, good sell price. You bought it at what, 60?
Yeah, 40 or 50 like that.
But not at 17 like somebody
Oh,
else.
right. That's why. All right. Yeah, let's get started on prim refinement. Okay, prim refinement.
Means giving instances different render consumed values such as color, roughness, dirt, or variation. So default prim, def x home card, f mesh body prepend. Bro, the good thing is we are so comfortable in reading this code now. Like we know what this code is doing exactly. And that is what we have learned in the last 3 months that you were saying that oh anybody could score 42
Yeah, bro. Okay.
on a 70, bro. If
All
you show this code to somebody else, they won't be able to say shit. Like they won't understand shit.
right. I see. I see.
Yeah. So okay. Car 1 and Car 2 share one native USD prototype, but each instance root authors are different from mask or color. Mm, but where did oh okay in prototype that shader color reader read the primbar name color name or color. Where is primvar?
Primware name car color. Input var name. That is primware over there, I guess.
Hmm.
Token inputs var name. Oh, it's using uniform token info ID USD primware reader over there, I guess. Because of that, that's how it's taking.
USD primvar reader float 3. Okay.
And then over here, the token ID is preview surface. So, oh, it's gonna take an input diffuse color dot connect. Oh, you see the difference in both the token selection, string token selection, and the change of options that you get, like the namespacing options that you get. So in the first one, we have input var name, whereas in the second one we are using the diffuse color. That is one of the
Mm-hmm.
input that usually preview surface provides, so that
Mm-hmm.
you can connect to the shader node graph API.
Mm-hmm. I see. Wait, what did you say?
Look at the token input. One of them has var name, other one has diffuse color as an input.
Token inputs var name, and then what are you saying? Token diffuse color. Where
Yeah,
is diffuse color?
Like in the second one, preview surface, sh- second trim, second shader, I would say the second shader. It's using preview
Mm-hmm.
surface, and the first one is using preview reader float.
Mm-hmm. Firmware reader float and preview surface.
And because of that, they do have different kind of inputs that are defined in the tokens when they're trying to connect with the shader API. Like when we're using dot connect, right? So what does this
Mm-hmm.
dot connect do over here? So dot connect will connect it with the shader graph node API,
Mm-hmm.
like in the background, and then it will provide basically the diffuse color to the surface, whatever
Mm-hmm.
that we are going to provide as an input. And from where is it reading the color? So it's reading the color from, I guess, prim reader, and that's how that shader node is connected to each other. Then, like if you do a horizontal scroll, you will be able to see it's reading from color reader dot output result that were defined above.
Mm-hmm. Extensible equal to true. Mm-hmm. So what is this? What is the inherited firmware called car color? Mm, Oh, refining native scene graph instances. That is why I was getting confused, bro.
What?
That it's first the example is showing refining native scene graph instances.
Hmm.
That is why I was like so confused. Why is it doing instanceable over here?
Hmm.
Okay. Card.usd it is referencing that, and then the card.usd has xform car mesh body prepend. Okay. Token output surface dot connect. Primary reader float 3, uniform token info ID POSD primary reader float 3. Mm, okay. Oh, so if you want to refine it with firmware, you need to make it so that it inputs diffuse color, car, looks, paints, color reader outputs, result, surface, token output surface dot connect, car looks, paints, preview surface, output surface. Read the firmware colored, car color, token input, var name. So whatever input it comes from over there, that goes to this, and then that will go to here, and that will give out the token output surface. And the car color would be firmware's this. Yes, okay. Parking lot, car one, firmware's car color red. Mm-hmm. All three also have the same prototype. The prototype stored shows the common geometry and the shader network. Each instance node provides a different inherited value. By constant interpolation often means one value applies to entire logical instance up to it does not mean a USD instance must receive the same value. Ordinary attributes would not work the same way. Nice. Okay. Okay, refining point instances. For a point instances, you do not have separate scene graph frames such as this. Instances are represented by array indices, so prototypes, mesh, primrose color, roughness. Array correspondence instance I012 positions. Uh-huh. Roughness. Okay. Oh, okay. Hmm.
Oh,
There was no traction on our stream today, bro.
yeah. Stream. Oh, like traction. Okay, okay, okay.
13 views only.
Bro, I'm
Why
telling
the
you,
fuck?
it's just matter of time. Once,
Mm,
once. What is the guy name? I forgot.
admire.
Yeah,
Admire.
he just needs to promote. Look at these two fuckers.
I think Sigraph is gonna be lit, bro. We made a correct decision. My goal by the end of this month is to basically just, have hands-on experience in Isaac Sim and
Mm,
then be able to create some sort of algorithm that trains a policy, like a policy model,
mm,
using Isaac Sim or like Cosmos or anything like that. Once we know that, bro, we
mm,
just need to do reinforcement learning after that.
mm,
Like we already have the machine learning experience.
mm.
We just need to learn reinforcement learning properly for like interviews and in the algorithms and stuff like that. We are golden, bro.
Yes. Yeah, that's that easy, bro. I just do that, do this, and then the live, and then people are gonna just keep throwing us on, keep throwing money on us, like, rich.
Yeah, bro.
Yeah,
I'm telling you, consistency,
consistency.
bro. We are on day 82. I think it's 82 today.
I see.
Stream settings, edit. Day 82. We have been consistent. We have not missed a day in 82 days.
My God. Oh my God.
Not even when you were traveling, not when I was traveling.
But we
We
would
did
have
it fully.
promised. We would our street that would end on, I guess, Friday. No, no, on Saturday. On Saturday,
Why? We are gonna be in the
because we would do
fucking hotel together, bro.
you would do traveling, like I would do traveling from
But we are gonna reach.
8:45, around 8:45.
We have internet in the aeroplane.
But the stream is not that good, bro. I wish if okay, like last time I did tried it on Southwest.
Bro, it was working. The only thing was the video ninja was like glitching out. So I think
So that is the thing, right? So if Video Ninja is glitching out, then
no, but you don't know how that's gonna work on a secure stream.
let's see. Okay, we'll try it on secure stream then. If it works, then
Hmm.
then I would also update the website with tried and tested with Starlink backed internet. Trusted by the best.
Yeah.
And then Elon Musk is like, my God, boys, what the fuck?
Hmm.
Uh,
Alright, I'll just
Scene, what was the full form of Scene Description Foundation? SDF, right?
SDF.
Yeah.
Yeah. Mm, mm. Oh, dude, we have not done this. Principles of scalable asset structure.
Mm. We can do it tomorrow.
What is an asset? Or all seen described by OpenUSD assets. What makes asset structure necessary? Planning an asset structure. Understanding your clients, understanding your collaborators, principles of asset structure, legibility, modularity, performance, navigability. Do prim property and resource identifiers effectively represent the intent and type of their representation? Does a structure facilitate iterative improvements of reusable content? Does the structure accelerate reusable content? Okay. Performance the structure accelerate content reader. Accelerate content read and write speeds for users and processes. Discovery elements while retaining fixes. Structuring an asset interface. Entry points. Next form server port. Okay, payload. Oh, so this is something that we already know. It's just giving it a official documentation. Payloads inherits inherit kind action and asset info. Okay, posting an asset interface. Every asset intended to be USD stage open are replace functional asset interface layer. As part of an access interface as well as public asset payment interface. Model the user and computational work streams as layers that contribute opinions to the asset. Provide one or more parameterized entry point prints as referencing targets and sources for metadata and hints. Nice to hierarchy into partitions with public and internal roles. Keep lightweight important fields left above payloads, modeling workstreams with layer stacks. Bro, France lost today.
Has lost. My God.
Hmm. Okay. Fastness reader, inform token, info ID. Alright, bro, let's quickly do these FAQs.
Mm-hmm.
What is USD? Why should I use it? Blah blah blah.
Mm-hmm.
Scene description plus composition plus scene graph. It is not limited to storing geometry. Modern programming languages are supported over C++ libraries with Python bindings for scripting and pipeline development. For implementation performance, bindings tools automation. Bro, I think we need to learn C++.
Yes, definitely.
Hmm. C++, reinforcement learning, and no USD includes file formats, but its defining features are its composition engine, high performance compose, scene graph, extensible schemas, asset resolution, file format plugins, and Hydra integration. If an option says USD is primarily a geometry interchange format, it is incomplete. USD is a scene composition system that happens to have file formats. USD is a scene composition system that happens to have file formats. What file formats does USD support? USDA, USDC, USD. Human readable UTF-8 text binary crate format can contain either USDA or USDC encoding. USD can also support additional formats through USDA file format plugins. And the distribution includes support for formats such as Alembic and Material X, Alembic and Material X, with differing read and write capabilities. Mhm. .USDA is equal to text. .USDC equal to binary. .USDA is equal to text or binary. USD can also, okay. What file format is my .USD? USD extension does not reveal whether the contents are USDA or USDC. The underlying encoding is selected through the file format arguments. USD default file format when unspecified USD is normally defaults. Bro, this is important.
Mm-hmm.
USD normally defaults to USDC. Renaming a file does not convert its internal encoding.
Mm-hmm.
What character encoding does .USDA support? USDA uses UTF-8. USD supports UTF-8 contextual content, sparse, and metadata identifiers, but does not automatically normalize equivalent Unicode representation. NFC normalization is preferred. Virtually identical Unicode strings may be distinct tokens or paths. What? I don't know what that means. What is UTF-8?
UTF-8 is the encoding that is used widely across text files.
Hmm.
Unicode text format.
What Unicode text format?
Yeah. That's what. I'll wait. Let me just verify it. I guess UTF UTF full form. I think that's what it is. Unicode text format. What the fuck?
Unicode transformation format, bro.
My bad. Yeah, yeah, yeah. Unicode transformation format.
Bridge between human language and machine code. Mm-hmm. Bro, if there is one language that you could learn to be like perfect at, what would that language be?
Like, what do you mean? Like, so it depends. What would I be using that language for? First,
No, like everything.
C plus plus.
Hmm. I would learn binary.
Yeah, bro, do it. Do it for sure.
Direct machine communication, brother.
For sure, bro. It's painful and also like kind of a retard thing to use back.
Bro, I'm saying if I could. I'm not saying I will.
No,
Like
but
if you got a wish,
you,
if you had a wish,
oh yeah, for sure, bro. Why don't you learn then directly like created?
assembly.
No, Neuralink. That's the best thing. Direct connection.
Yeah.
Direct, direct, direct.
Hmm. Hmm. Hmm.
Yes, bro. Yeah, bro. Continue. Let's one already. Let's complete this shit.
Oh
Um,
yeah. Yeah. So how can I convert USD files between binary and text? So from binary, use USD card and specify either destination extension or USD format. Outputting to plain USD defaults to USDC unless USD is explicitly requested. So USD CAD input dot USD and output is this. Convert explicit USD convert to explicit USD. Keep USD extension but force USD encoding. Okay. What data types are supported? USD provides a predefined collection of basic SDF value types such as Boolean, float, double token, string vectors, matrices, quaternions, asset, and arrays. New fundamental value types cannot be added through plugins. Yeah, this is what you were telling me.
yeah.
Can add custom schemas and attributes. Cannot plug in a new fundamental SDF data type. A custom schema can use existing value types but cannot invent something new like SDF value type name, like a new native value type name. Okay. What does a USD file look like? A USDA represents hierarchical prime time properties, metadata combination of such as references and heads and variants using readable text syntax. A USDA file contains the authored opinions, not necessarily the complete final composed scene. Mm. Mhm. Remember, a USD file contains authored opinions, not necessarily the complete final composed scene. Okay. Scene description and composition. Should I combine layers using sublayers or references? Before sublayers, when the layer shares the same namespace and should overlay one another as a layer stack. Use references when you need namespace remapping, selective frame inclusion, asset reuse, encapsulation, or composition beneath stronger local opinion. Prefer sublayers when the layers share the same namespace, and should overlay one another as a layer stack. Use references when you need namespace. What does that mean? Prefer sublayers when layers share the same namespace and should overlay one another as a layer stack. Use references when you need namespace remapping, selective frame inclusion, asset reuse, encapsulation, or composition beneath stronger local opinions.
So that part means, or like whenever we want to have a selective selection, like in references, right? So let's say you have a .usd file, and you have multiple prims in that file, but you only want to get or you only want to get or load a single prim from that, right? So in
Mm,
that scenario, you would try to use reference or any other composition arc, maybe payload. But in a scenario where you do not want uh, that kind of selection, right? Then at that point, or you want to load the whole layer stack all at once,
mm,
or the whole layer in when you try to compose,
mm,
then at that point you will use the layer stack, even though they
mm,
have any same namespace. Like I think I would say same namespace means the same names. That's what my
mm, mm. Over the entire namespace, insert selected prim subtree does not remap namespace, can remap into new namespace. Simple and efficient, more composition machinery. Easy edit, target selection, useful for usable assets, opinions of other position, opinions enter who are important liberties, some consequences, direct sublayer, local opinions, variants. Okay, got it. My shoulder is fucked, bro. My right shoulder is
Or just
absolutely
do you have ice in your house?
yeah.
Yeah, just do some icing and don't push tomorrow. Just do some
Yeah.
cardio if you
No,
feel like.
I already have legs tomorrow.
Yeah, then that's all good. Just put some icing today. Why before going to sleep, just do like 20 minutes or 10 minutes
Yeah,
of icing on that area. Or if you have ibuprofen, you can take that as well.
I do have ibuprofen.
Yeah.
I don't know what happened, bro. I've been doing uh, incline bench press with
Did you start?
65s.
Yeah, like incline bench press do put a lot of load on your shoulders. because they are doing a
Yeah,
lot of lifting at some point.
yeah.
You do like a warm up of pull ups before starting to hit the chest today or not?
Bro, I do a complete warm up every day, bro.
Well, then that's all good then. Yeah.
Yeah. I do cardio before working out, so
Oh,
my body is completely warm.
I see.
Yeah. Okay. What happens to an over if an underlying prim is moved and renamed? The over remains authored at its original path. If no prim is composed there anymore, the over becomes orphaned and its opinions no longer affect the moved renamed prim. USD does not automatically chase arbitrary namespace changes between independently edited layers. Called weak layer, world book, strong layer, over world book after weak layer renames it orphaned. Okay. And over target a path, not the permanently identity of an object. Many can delete reference or another list edit them. Many can delete a reference or another list edited item. When can you delete a reference? The effect of delete depends on what is being list edited, metadata items, and relationship connection targets can generally be deleted across the composition graph, but composition arcs can only be meaningfully deleted when they were introduced in the same layer stack. The effect of delete depends on what is being list edited. The effect of delete depends on what is being list edited, metadata items, and relationship connections. Metadata items and relationship connection targets can generally be deleted across composition graphs, but composition arcs can only be meaningfully deleted when they were introduced in the same layer stack. Custom list edited metadata, string tokens, string token integer metadata item can be removed from composition context. Custom list edited metadata, string token integer metadata items can be removed from stronger composition context. Relationships and connections target can also be removed across composition, but use the target path as translated into the final root layer stack namespace. Wait 1 second. When can you delete a reference or another listed item? The effect of a delete depends on what is being list edited. Metadata items and relationship connection targets can generally be deleted across the composition graph, but composition arcs can only be meaningfully deleted when they are introduced in the same layer stack. String token and integer metadata items can be removed from stronger composition context. Targets can also be removed from across composition, but use the target path as translated into the final root layer namespace. Compositional references, payloads, inherits, and similar arcs obey composition encapsulation. You may delete an arc introduced in the same layer stack. You cannot normally delete an arc that arrived from inside another reference. Hmm. Okay, so this is important. Short.usd cannot directly delete internal share.usd reference because that reference was introduced inside the reference environment layer stack.
But you can delete the environment.usda.
Hmm. Over here it says you may delete an arc introduced in the same layer stack. So I think you can delete environments. Variant selection can pierce encapsulation, but using them to replace internal references may cause a strength inversion. Can pierce encapsulation, but using them to replace internal references may cause a strength inversion, making the newly introduced reference opinion stronger than immediate override. Values can be overridden. Internal composition structure is encapsulated. What does that mean? This is a little iffy. Wait, let me see about this 12th question over here.
Dude, value can be overridden, value composition.
Yeah, yeah, I know that, but orphan. Mm-hmm. USD allows several kinds of data, including observer to be illustrated, that is, depending, appending, deleting elements in a strong guide. Strong layer from list that has been built up in weaker layers. In addition to all combination of except sublayers, you can also list edit relationship for any data type that can be list edited. It is syntactically legal and semantically meaningful to place a delete operator. Mm-hmm. List editing had delete, right? Yes.
Yes.
Delete. Okay. Reset to explicit. Append, prepend. Append was to the back. Prepend was to the front. Delete is delete. Reset is to. This causes the resolved list to be reset to provide value or values, ignoring all list operations from the weekend level. This is also important. Reset to explicit. Okay, so this we understand list editing string token int metadata. Custom list edited metadata is the simplest case. Custom list edited metadata, the items can be removed from the list actually ordered set. Since list editing in USD reduplicates items added more than once. Anywhere in the combination graph, list edited relationship and connections. Similarly to custom list edited metadata, relationship and connection targets can be removed and added. I know that meaningfully deleting composition I imposes some restrictions because of the some central aspects of encapsulation in USD composition. Encapsulation means that wherever you use a reference, relocates payloads, inherits variant side or specialized arc on a frame, the result that gets woven into the composition is immutable by stronger layers. Values can be written. Bro, this is important and tricky.
Encapsulation means whenever you use a reference to locate the results gets woven into. But
Values can be overridden and objects can be Wait, encapsulation means that whenever you use a reference, relocate, blah 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 on a prim, the result gets woven into the composition is immutable by stronger layers. So, okay, values can be overridden and objects can be added, but the internal referencing structure of the arc's target cannot be changed. This is important for several reasons. It makes the Liberty's composition algorithm explainable and more easily understandable because it's properly recursive. It enables efficient composition engine implementation. It enables more efficient composition engine. So what is it saying that once like a frame is defined by a composition arc, it can be its value can be overridden, but the and objects can be added, but the internal referencing structure of the arc target cannot be changed. This is the
You
most
cannot
important.
change the referencing structure inside the reference prim. That's what it is saying over there, or any payload. So let's say you
What,
load.
like for example,
So for example, you have a prim word, and
we
inside
said prepend,
what?
we said okay, prepend reference card or USDA.
Yeah. So when you do reference card or USDA, you will load that reference in over there, and the only thing
Hmm.
that you can do is use over to override any values. So for example, maybe that reference is
Hmm.
trying to bring a value of a car wheel or car color, right?
Hmm.
And you can override the value of that car color to something else. But what you cannot do is, let's say you there is a prim inside the car that is called wheel, and you want to delete that prim, right? You cannot do that inside a reference, since it's a reference file, it's not a layer
Hmm.
file, right? Or you can only make changes into layers, or layers are
Hmm.
applicable but not composition arcs that are specifically referenced out, or that are such as payloads, inherit, and variant sets. That's why we can only use, I think, edit variant sets, and that too only inside the file, not into the layer that you're trying to input it into.
Hmm.
So in that manner, I think it's talking about over there. Like it says, because it allows great sharing of composition sub results. So maybe that same
Hmm.
composition is getting used somewhere else. So for example, let's say again, let's say there is a file that is trying to input car, and there is another file
Hmm.
or layer that is also trying to input that
Hmm.
car, right? Or there is another developer that is trying to input that same or reference the same payload. Now, if you make a
Hmm.
change to that payload, then for wherever that file is being referenced will also get updated,
Hmm.
right? To avoid those things, that's why we have inherits. Like if you are inheriting a file, you can make a change
Hmm.
accordingly. You can make a change into the file directly into the inherits, so that
Hmm.
all the change gets propagated. But you cannot
Hmm.
make any change onto the reference from a layer. Like you cannot make changes from higher level to a lower level. You can make changes onto lower level to a higher level that are going to reflect once you make a change onto a lower level file. That's
Hmm.
referencing or payloads or variances, whatever we are defining over there.
Oh, they've shown an example over here.
Yeah. Bro, like, yeah, let's end the stream, bro. It's getting late. I need to wake up.
Oh, okay. I'm 125. I'm on 13 questions. What is the difference between over and a type of staff? Okay, I'll end it.
Alright.
3 hours. Okay.
क्या बोल रहा था बोल कुछ बोल